Starting the stream up. Second time in the day. All right. Blurry 160p image coming right back at me. Hello. This is the third stream in a series that I'm doing where I'm resurrecting an old tool. So I'm working on a binary parser. Oh, why is this? There we go. Working on a binary file parser, and we're looking at the GIF format and getting it to parse out a GIF file. And I was working on this morning, and then I kind of had to run to a meeting. Where I was on this part where we have a global color table, and we know the color table size. I wanted to pass it into the global color table component here so that we can loop for that size. And yeah, that's basically what we're doing. Hey, 715209. How are you? So what I ran into was these arguments weren't actually made available, so I was getting this error about size unfound, right? So I think this code that I was writing here should fix it, but I'm not completely sure. I think the last thing I wrote was that, and yeah, I didn't try to build it yet. And I also wasn't sure what is component allow overwrite should be. What's allow overwrite? Whether or not to allow overwriting in these. Okay, that actually won't happen, so we don't have to worry about that. By default, it's true. Actually, we don't want it to be true. We want it to be false here, right? Because we don't want two actual arguments to have the same name. There's a fly buzzing right in front of me. Go away, fly. I got it. Okay, let's see about building this thing. Build. Huh, it built. Imagine that. Let's try running it. Still size is unfound. Okay. So am I running the right thing? Decompose, yeah. It looks like the right time. Size is still unfound. Okay, so this code didn't work. Not equal to null pointer. Dereference that reference with a given value. Let's go into dereference and make sure you got new value. New value. It's if we get down to it's not there, new value is not null, it's supposed to do this. So it should have gone in there. Let's add a diagnostic message. Since there's one conveniently there, we can copy it here. We can say that this is created. Build it. Run it. Okay. Global table color created. Then it created I. Okay, so it didn't actually create the size. Oh, wait. That's probably the problem, right? The name is probably not right. Okay. Wait, we have path plus key. Key, what is key? Key. Key is the references identifier. Okay, well, that's what it should have been. Should have been size, right? Maybe it's not. Hold on, let me add, just for the heck of it, let me add like an XYZ here. And then we'll just apply a dummy argument. So like 1, 2, 3, and see what I get. I was created. Global table color was created, but it didn't. Oh, maybe it's because it's using the same name twice. Let's add some more debugging. When in doubt, add debugging. Okay, so another thing of debugging. Actually, it's not really an error. That's okay. We'll just pretend it's an error. Let me go to where I'm calling this. Right here. So we'll put a little message in here and we'll say, this is what? It'll be in arg, right? Arg identifier. It's already, that already is a C string, right? Okay, so that. Dereferencing that. Okay, build. Run. Huh. It's not going into that at all. Okay. It should have, unless that is null. Let's put another one so I can see it happen. So this is like I need to check this also. Checking for arguments too, and then this would be I guess we use path, right? C string. Okay, and then let's have another message here. I wanted a message here anyway, right? This would be that this was going to be a warning. Or should it be an error, actually? Ran out of parameters. Well, it's, I guess warning's fine. So no parameter given for, let's have a %s and then have the path and the arg identifier in there. Okay, build it and run it. Okay. Here we go. Checking for arguments to GIF, local screen, global color table. No parameters, no parameter given for size. Okay, but we did give a parameter for size, right? So there's line numbers there. 30, line number 30. Column 9. Okay, let's hide this. Column 9 through column 57, which is way out here, right? Yeah, so it's that. It's saying that no parameter is given for size, but that is the parameter I gave. And so it should have a value there, right? So maybe the parameters aren't being parsed correctly. Okay, why would that be true? Okay, final references to parameter. Right, here's where we filled them in, right? Right here. If expression left-hand side, is that correct? Hold on. I have to go to the grammar to see how this works. This would be a function call, right? So that's a form of an expression? No, this is a format, a component, whatever. It would be a statement. Well, how did I get balloons? Is that this thing? Let's see if this works. Yeah, that's a new macOS thing. It's funny. Like I should probably turn that off when I'm streaming. Gonna accidentally cause those reactions to happen, right? Yeah. Silly. All right. Statement body. Yeah, here we go. This is what it is. It's a part specification. So it's this expression list, right? Args. So we put args in args. That's fine. That's where we're looking, right? We're looking in args. No. Wait. Expression function. Oh, hold on. Hold on. We're not in function, we're in part. And we're in a statement, not an expression. So we're looking in the wrong place. Totally looking in the wrong place. So what is this listed as? Parameters to the format, but really it's... Okay, yeah, there are two places because it could be a function call or it could be a format. Both places we're going to end up decomposing, right? One is going to be yielding a part, another one's not. Right, so that means there are two places where this needs to be done. So I guess I should look and see what the grammar is for a function call. So that's an expression, right? Expression. Here we go. So where's the function call in the expression here? That's the statement. I need to look for in the expressions. Expression. Here we go. One of these is function call, I think. Function call. There we go. So there's the args here. Okay, that is stored in the left-hand side for some reason. I guess because the thing is an expression, not a component. So it uses a different structure. It uses expression, which has, it's meant for like left-hand side, right-hand side. Okay, so that makes sense. But I'm going to need something similar to this for args, right? Okay, so we're going to look for, I guess that's execute statement right here. Yes. Yeah, before we decompose the part, we need to expand the arguments. So I guess that could go anywhere here, right? Part. Let's just paste it here. If statement args, is it not statement? Is there no statement? Okay, it just took a while. So the parameter is statement args, right? And then we go until we get to back to the first one again. So we evaluate that expression. Okay, this return doesn't make sense. What do we do if it's null pointer? What does a null pointer mean for an expression? An error occurs in evaluating the expression. Okay, so what happens if an error occurs here? Then we do this thing. Okay. Yeah, so that would go there. Okay. And then this is part then. Okay. Cool. Let's try that. So CMake tools, build, and run again. Oh, it got further. We have a problem with unable to promote. There's something's a nil. Size is nil. Okay, cool. So checking for arguments, it has size created. Size.x, why is it doing size.xyz? Oh, the path is wrong. And we need to start off with a new path every time. Yeah, that's not right. We don't want to create it under size. And why did it do xyz dot size? That's really weird. Okay, we need to fix that. Is that in here? No, it's not going to be in here, right? It's going to be in decompose, right? And here where we deal with the parameters, right here. Arg is a reference. Oh, I think I know what the problem might be. The args is a reference chain, right? Yeah, okay. I think there's a problem here in that when we form this expression list, or in a part, it was what? Part, where are you? Here, part. Right, it's also an expression list, it's an optional expression list. So expression list, how does it chain them together? It does it through the next field. Yeah, so there's a problem here in that this is a list of expressions, but we're also using, I think I was also using the next pointer when I have dot notation. Hey there, winter coding. What are we parsing? We're parsing, hold on, drum roll please. We are parsing lol slide, which looks like this. So I made a parser that, hold on. I made a parser that is not just for any one particular file format, but can adapt to whatever file format you can specify using a domain-specific language. So this is GIF, right? It consists of a header, logical screen, which has the width, height, all that stuff. And I figured that out by downloading the very ancient specification about GIF, right, which was made in 1987, updated to 1990. But it talks about all the parts of things, including decoding the LZW compressed pixels. But the part I really care about to test my parser is just the outermost grammar, right? So I'm basically converting this into the domain-specific language that I made for the parser, and then just making sure that the parser works. Because the last time I worked on this before the streams this week was like 5 years ago. So I don't remember a lot of it. Like I was relearning my own syntax that I have described in a Bison input file, parser generator, right? So it's like grammar rules, and then what code to emit when a certain rule is matched, all that stuff. I wrote this like 4 or 5 years ago, and I forgot half of it. To be honest, I forgot most of it, right? So trying to get this work, and I'm also finding that there are things that are missing and there are things that are broken in it. I'm trying to repair it. And then the ultimate goal is I want to get this project ported to Rust, and I want to add a user interface to it. And I basically want to have this tool that I can use whenever I encounter a new kind of binary file and I want to look at it. Like and I don't have a reader for it, or if it's the file's broken in some way, I want a way to like inspect the parts of it and find where the errors are. So yeah, I joined the Rust cult a couple of years ago. Yeah, I did. Ferris, yes. In fact, I made this guy and wrote the firmware for it in Rust. That was last year's project, the keyboard. If you're interested in that, there's a YouTube link. You can get the summary. You can even watch the streams if you want. But yeah, that was such a successful project that it kind of cemented firmly in my brain that I like Rust and I like to do Rust programming in my spare time. And since I wasn't always a Rust fanatic, I have got a lot of code written in a lot of other like different languages, and this parser called the DataDisintegrator is a favorite project of mine, and unfortunately it's all in C++, so I'd like to get it resurrected in Rust. But I first have to make it work the way it was designed, and then I can piece by piece port it. It's got a Lexer using Flex, and someone in chat already gave me a good suggestion on what to an alternative Rust crate to do basically what Flex does for me. I still need to find a solution for the parser generator, or the grammar matching, but I found a couple leads on that looks promising. I just haven't followed up on them yet. Programming language has been Rust and C#. C#'s pretty nice. Not many stable frameworks in Rust yet. It depends on what kind of Rust coding you're going to do. Like when I made the firmware for this, the frameworks were very stable, actually. I didn't need to do any of the USB stack, for example. GUI framers, you're right about that. But my new favorite GUI framework is eGUI. That was a little like getting back into streaming project I did for about 25 streams last month. I think the biggest downside of eGUI is that it's really it's like an add-on. It assumes that you already have a main app structure and a way to draw the GUI. What OS am I using? Hey, there's an OS command you could have guessed, but here I'll type it for you. Xubuntu, running on Parallels, and a Parallels VM on a Mac Studio. And because it's on a Mac Studio, I can do this, and we can get that cool effect. Mac OS for you. Anyway. Yeah, nice. I'm glad you agree. Right. So I think the bug I was looking at just now is that my expression list uses this next pointer to chain expressions together, but I think the dot syntax also does the same thing. So if I look at where that's used, I think it's in ref. Yeah, when you have ref something dot something, look at that. I also use the next pointer. That's the problem. I can't use the same next pointer for both dot chains and expression lists. You always checking on, are we GUI yet side? Good set, yeah. Right? I agree. We have, are we GUI yet? Yep. This is where I went to kind of look to see what would be a nice GUI layer. And the first thing I picked was actually full tick. Full tick is pretty okay, but the problem is it's not pure Rust, and it's got a huge like code base built up over the years in C++. Plus side though is it ran just fine on Mac, Windows, and Linux as long as I got full tick itself installed. So I played with that for a while, and then eGUI was attractive because I also wanted to play with WGPU, and eGUI's got some nice integration stuff with WGPU. Also, you can put it into web pages. So yeah, I like Are We GUI Yet? There's also Are We Game Yet? Are We Game Yet? If you're interested in game development. I think this is where I found the physics engine I was playing around with. Physics. I was playing around with rapier, and it's on the list right here, right? Playing around with that one. There's also, are we web yet, right? Yes. I kind of like the idea of the are we blank yet, because you can kind of like guess, well, is there a page for games? Are we game yet? Is that a thing? Yeah. Cool. Are we web yet? Yeah. Currently using Avalonia. I was using Avalonia too. In fact, we could see that if you look at my CMake file for my WPF GUI. Guess what you'll find? You will find somewhere in here. I thought it would be in here. Is it not in here? Avalon edit. That's the same thing, right? Or maybe this is the editor for Avalonia. Or maybe it's a total coincidence. I don't know. But this was a pretty slick code editor that I found in the .NET marketplace or whatever. It was pretty cool. Avalon is a different library. Ah, then it's a total coincidence. It's pretty neat. Yeah, the one thing I don't like about .NET and C# is that they're kind of like mostly Microsoft stuff. Same thing like, what is it? Swift, right? Great language, kind of like Rust, but it's kind of mostly in that Apple area, right? So I'm kind of into cross-platform stuff. Rust is very attractive to me because you basically can develop on any OS and then probably get it to work on any other OS as long as you stay away from platform-specific crates. Mind if you link Avalonia site? I don't mind. That's cool. I'm gonna need to fix this. And I think the way I'm gonna fix this is that this type, ref, the type associated with ref, reference, oh, thank you. Swift team is rewriting all of Foundation in Swift, which should make it very cross-platform. That's cool. They're kind of late to it though. Yeah, Rust has got them beat, I think. But that's fine. I don't want to say anything bad about it. I just like things that are very cross-platform. Very late? Yeah. That's okay. I mean, it's not like you can do C# on non-Windows platforms very easily. It's got some hoops you got to go through, which I guess Unity has been doing a lot of things to help out with over the years. Okay, anyway, I just realized that we have two different types. We have reference and we have expression. So maybe when I was getting mixed up between the two, maybe we don't have a problem. So expression list, I think maybe it's okay to chain them. This thing with the next, as long as the reference uses something different. So what does a ref use for its chain? Yeah, it's a ref dot. So it is fine then. So then why am I getting? Oh, I know why. Because I'm using dereference. Okay. Yeah, it's because I'm chaining references together, which I shouldn't do. Here, right? This arg is not really supposed to be a reference, right? This type is wrong, I think. Attributes of the data object to any values passed in its arguments to the overall format. Yeah, this should not be reference. This should be identifier, I think. I don't want references here. In fact, it says it in the comment here. It's a list of identifiers. I don't want reference. I want identifier. I think that's the main problem. And then so every time, okay, I know how to temporarily fix this. Instead of using arg here, we would make a new reference and dereference it and then destroy it. And I did that elsewhere, right? Find where I did that. It was in a local statement. Statement local? Here it is. So I want to do this, create a reference, set its identifier as a copy, dereference it, and then destroy the reference. It's like a temporary reference. So let's do, this will be a workaround until I fix it properly. Actually, I'm going to keep this because it's not going to start out, args is not going to be a reference. Actually, that's the wrong place. We want to go to decompose. Right down here. This should not be a reference. This should be an identifier chain of some. Oh, maybe that's why I use this type. I use this type because an identifier doesn't have a link in it. That's right. But it led to this bug, which I want to sort of avoid. So maybe I make another type which is just identifier list or chainable identifier. Yeah, okay. Let me add that to my to-do thing so that I don't forget. So define new type chainable or identifier chain. Identifier list or something like that. Give it a formal name here. Define new type identifier list for formal arguments to functions. Well, actually, what do I call it? What do I call the thing in the grammar? It's called a format, right? Yeah, it's a format. So it's this thing, this ID list. Right, and that's sort of the clue I should have had, right? ID list. If I look at it, why is ID list of type reference? That doesn't make any sense. It should be a type ID list or identifier list. Reference is, sure, these are both reference types. These should not be. Okay, cool. So I'm just kind of reinforcing my own decisions here. Define new type identifier list for format arguments to formats. Okay. They actually made a service for companies to port WPF apps to cross-platform. It's a fork of WPF and allows for true cross-platform. I liked WPF. I thought that, well, I liked as in I don't, it's not that I don't, I know, it's not that I no longer like WPF. It's that I don't like to be locked into the Microsoft ecosystem anymore. But there are certain things about WPF I really liked, like the bindings. Bindings were super cool in WPF. And I have yet to see something as slick as the way WPF did bindings in any other frameworks. I really miss that. Avalonia is also cross-platform. It supports mobile, web, and desktop. Even Raspberry Pi is supported. There we go. If it's supported on my keyboard, I'll definitely get behind it. I think I love Avalonia because it's a similar WPF. Well, let me take that link then. Copy link. Let me put it in my private notebook in the area that I reserve for looking stuff up later. Look at later. I'm going to say paste, and I'm going to say that winter coding told me about it. You know what I'll do is after I look at it, I'll report back in my Discord. If you're not watching, if you want to see what I said about it later, probably like in a couple weeks, just come back to my Discord server and I'll say that, hey, winter coding had the suggestion. I looked into it. This is what I thought about it. All right, so back here, my temporary solution to this was not to dereference arg, but to create another reference that's temporary. Oh, and I lost the clipboard. That's okay, we can find it, right? It was near where we call destroy reference. I guess I call it a lot. Yeah, this. Oh no, my Roomba has a error 6 in the other room. I hope someone else in the house will rescue him. We need to go to decompose down here. Might have to run out and save my Roomba because he stopped cleaning. I can no longer hear him going, and that makes me sad. Okay, so that, and then we're going to destroy the reference here, and so this reference will be basically just copying the identifier out of the arg. Identifier, right? Arg identifier. It's basically copying the identifier out of the argument, not using anything else from the reference, making a temporary reference, dereferencing it, which adds the value, associates the value with that, the name of the in the reference to the current context. Destroy that temporary reference, and then it'll be added. So I think this will work. Build and run. It didn't do anything. It didn't do it. Oh wait, I think I know what I did wrong. You probably noticed it, but I forgot to put reference here. That would have helped. Let's build that. I went through all that trouble of making the reference and I didn't use it. Oh look, it worked. We got through the color table. So we parsed the whole color table. Look at that. All those pixels. In fact, there's so many of them that I lost all the debug messages before that. So I'm going to have to do like a less on that to see it. So what happened to all my debug messages? I thought I left them in there. How come we don't see? Oh, because they're to the error stream. So I have to do what? I have to do 2. I have to do 2 again. Was it greater than and 1? And then less? There we go. So now we got our errors mixed in. Cool, so here are our errors. So what I want to see is that it created size and it created my XYZ dummy, and then they're separate things. So where did that happen? Oh, here we go. So dereferencing size created. Dereferencing XYZ created. Perfect. So I don't think I need those debug messages anymore. We can get rid of them. There's one of them. Don't need that anymore. We want to keep that, right? That's a warning if I don't provide a parameter, and we can test that by just removing this. Like that, right? Now we should get that error. Yep. No parameter given for size. Look at that. Perfect. And then we end up getting the size unfound inside the function, which makes sense. Okay, cool. So that test successful. Let's remove the 1, 2, 3. Don't need it anymore. We don't need this XYZ anymore. Okay, and then I had some diagnostic messages. So this to do is done. That's great. And then inside of dereference, I had some debugging in here too, right? Yeah, this created, we don't need it. The unfound is still an error. And that's it, right? I've been really lucky tonight, and I have not had a compiler error. First try, every time. With the compiler, at least. So that's great. Now we're parsing all the way through the global color table. 2 greater than 1. If you do 2 greater than and 1, what it does is it feeds stream 2, which is standard error, into stream 1, which is standard output, and merges them, which is kind of cool. I'm not sure what 2 greater than without the ampersand does, though. What does that actually do? Does it do the same thing? I think that doesn't do the same thing. See, when I do 2 greater than ampersand 1, I get the error messages glued with the non-errors. But if I just do a greater than 1, I don't get the errors. I don't think that they're in there anywhere. Yeah. And I think it's because my streams are buffered. We're getting them separately. They're not mixed together properly. Right? I think that's right. Because we shouldn't see this until it's already like parsed down there. In fact, if I don't do the piping at all, and don't do the redirection, I think. And then if, well, it's going to be too much though. Buffer's too big. I pipe it. That's interesting. So where are the errors then? Didn't see him there and didn't see him out here in the shell. Huh. Yeah, like that warning. When I do piping to less, it's not there at all, right? Like it's not nowhere in there and just disappears. Interesting. That must be the shell doing it, right? Okay, anyway, we're parsing through the global color table. That's neat. Can I just do a report now? Okay, cool. So here's the report. Yeah, it's showing all the things sorted, so all the reds and all the greens and all the blues and all that. So the report's not so great because it does this sorting, which means it's not in the order in which it was parsed anymore. But it is kind of cool to see the tree-like structure. That like here's the header, and then logical screen is what holds the aspect ratio, color index, resolution, all that stuff. I think my favorite is still the debug level 2 because it shows it in the order which things were parsed. So we have the header, and then we have the width, the height, and then we can kind of see the logical structure by the dot syntax. The report's actually awesome. Why, thank you. What this was sort of meant for is eventually I want to actually have this in a real GUI that we can collapse and expand things and also like show them in either sorted or in parsing order. Kind of like the formatting. Yeah, it's meant to like look like a tree like data structure that you can imagine in a GUI would have like little ticks where you can like expand and collapse them. Oh, but I can illustrate one property of my parser that's kind of unusual. You see how blue became an array? This is like one of the really cool things that I liked about the design I came up with. I didn't actually declare any arrays here. If you look at my syntax, there's no arrays, but there's a hidden array context. The way it works is in this global color table, when you have a for loop and you define something inside of the context of a loop, then these elements become arrays of size elements under the global color table, which is what you want when you think about it, because unless I made an outer component called pixel, when you want to dereference from the top, like you can see it in the report, not in the report, but you can see it in this list, right? Where's the little button for expanding? There it is. You can see that you want to reference this as under the GIF. There's dot logical screen, dot global color table, and then you want the first red, the second red, the third red, and so on, right? So I didn't have to declare an array, and I didn't have to like parse each red value and then store in the array. It's just kind of automatically done contextually by the fact that we're in the context of a loop. Was it accidental or intentional? It kind of matched just what I wanted as far as like how to organize the data. So I guess you could say it was accidental. Ahoy hoy, Robotic Head, how are you? I'm just explaining here how the parser I designed that I'm working on right now operates in how it forms data structures out of parsing bits. So if you missed it, we're parsing this thing, which looks like that. But really to the computer, it just looks like this. And I'm parsing it with a generic parser that I wrote in C++ that it doesn't know how to parse anything on its own. It just has like the basic tools for parsing strings and bits and integers. And you have to describe to it how to parse the file that you're going to give it. And you do it with this domain-specific language, which kind of looks like a combination of C structures and C functions. So like global color table, right? It's both a function and a data structure, because when we're parsing, it's the function that describes what steps to take to parse. So we go into a loop, and from 0 up till but not including size, we parse 8 bits red, 8 bits green, 8 bits blue, repeat until we have size combinations, right? So if like size is 256, then we'll end up with a global color table of 256 color values, each with a red, green, and blue component, right? So it looks like a function when it's running, but in the end, you end up with a data structure, which is the global color table. Looks like this. This is one way to look at it. It looks like a structure with 3 arrays in it, and the arrays are all the same size, right? You could also turn it around and just have an array of pixels, and each pixel has a red, green, and blue component if you wanted. You can also look at it this way, that in a tree-like structure, under the GIF, there's a logical screen, which has a global color table, which has a blue table, a red table, and a green table. Right? It's just another way of looking at it. But that's what's kind of funky about this parser, is that the language you describe the format in looks like a function and ends up like a structure at the end. And so we convert loops into vectors. You can imagine if I had a nested loop, like if I had 2 for loops, one inside the other, we would have a 2-dimensional vector for every inner element. So yeah, I'm glad that I fixed that. That I should test it, because I'm using it in the context of a part specification, but there's the alternate syntax where I can use it as a function, right? And I might have to make a contrived example to test that. Let's make a contrived example to test that. Let's have like, actually, this is a good thing to do. We can say if signature is not equal to make signature, or make constant, or let's just call it constant signature, then actually I don't even know if I have this. I think there's an error in my syntax, but I'm not sure. But see, here we're using, like, in a function context, not a part specification. This is a part specification, and so is this. It's a part specification. It looks like a function call that is like a statement. And what it's doing is it's specifying a part of the overall data, right? It means we're going to have a global color table right here. So it looks like a function call, but it's actually parsing data, whereas this is not parsing any data. It's actually just calling a pure function and saying, given this string, give me back something and compare it to what I parsed for the signature part. So this I also fixed, but I need to test it. So we specify it exactly the same as we would a part, but it doesn't actually parse anything. In fact, if we parse something here, I think I get an error. So what I want to do is just have like an if name equals signature return GIF, right? Else if I'm gonna leverage this because I'm gonna have like version. It's gonna be 89A, right? And then we'll just have a catch-all else. Actually, I don't even think I need a catch-all, because I was gonna say return nil, right? But I think the default is to return nil if you fall through. So yeah, I can basically reuse my function here and say the version had better be 89A, right? I think I'm allowed to put a string here, but I'm not sure. Let's try this. So error bad signature, error unknown version, or something like that. Of course, this is kind of bad because according to the spec, there are actually 2 values for the version, right? It says it under here somewhere. Yeah, we can have 87A or 89A, right? But I think that'd be quite a challenge these days to find a good GIF file that's 87A format. Yeah. Certain things actually require the 89A format. Did you know that GIF was invented in 1987? All right, let's see if this works. Actually, it did, but I don't want the less, right? Or I guess I do want less. Actually, I want to kind of include standard error. I can type the character correctly. There we go. All right. Yeah, this problem again. Okay, there. Okay, it doesn't actually print anything. Oh, I forgot to get rid of that error. The checking arguments. Actually, it's probably a good thing because we wanted to make sure we're doing that. GIF header constant, right? So let's force it to not work by let's say we pretended we wanted 87A. There we go. Error, unknown version. So it works. So similar to how hex editor tools use a pattern language to parse the file. Depends on the hex editor tool. Like if we're talking like generic hex editor, those don't really parse anything, right? They just kind of show you the raw bytes. Maybe the data inspectors in some hex editors, because this is certainly taking the location I clicked and saying, hey, maybe you're looking at the byte, or maybe you're looking at a word, or maybe a 32-bit word, or maybe you're looking at it as a string, right? If I click here, it'll see it's a G. If I select three things, I guess that doesn't work, but maybe a data inspector for a hex editor, like maybe Wireshark. Talking about tools such as 010 editor, I actually never looked at that, but one thing that my parser kind of works like is if you're familiar with Wireshark, right? This thing, it's like a protocol analysis tool. Can we get a screenshot of that? How about if I go to Wireshark image search? Yeah. Can we just blow that up? So they have some, right, when you click an area of the hex codes, it'll actually kind of like interpret it. And it's kind of similar. My understanding is the plugins for Wireshark kind of act in a similar way to my my parser. They will they know how to like someone has written a script or in a domain specific language of some kind, like how to parse different protocols, and they plug into Wireshark, and Wireshark just uses them to interpret what the bytes mean. So yeah, I'm kind of writing something like that, only very, very generic. It's not just going to work for protocols. It's going to work for any kind of binary data. Yeah, but the same kind of concept. I don't know how Wireshark plugins and protocol analysis tools are made, but I wanted mine to be totally generic. So I invented a language to specify how a format is, how the syntax or grammar of a format, and then the tool just doesn't know anything about the format. It follows this like a recipe. It follows it from the top down. It says, okay, the next thing is going to be a header. Okay, we're in header. The next thing is going to be the 24 bits. It has to be a string and it's a signature. Then this had better be true, otherwise we error out, you know, that kind of thing. And it just blindly follows the recipe, just like you were running a program. Here's the structure of our IM hexes pattern. Let me click that and open in a new window. I guess we'll open it in the virtual machine since it looked okay. This is code though. What were we trying to look at there? The structure for their pattern language. Oh, you mean like how they describe a GIF? Struct header. So is it the same way like you define a struct in, I guess this is Rust, right? What language? No, hexpat. Oh, this is a domain specific language. Oh, that's cool. So yeah, look, that is very similar to what I have here. And I could have done it, I could have actually done it similarly where I called this a header. But I made that optional in my language. If you don't actually give a name, then it takes the part type and just uses that for the name. So here they have to have a name that's separate from the part type. But yeah, it's very similar to, yeah, and they have this, which is kind of like, but what I was doing was, I'm doing this kind of contrived because I wanted to test function arguments because that's the thing that was broken this morning, right? And we fixed it tonight. But yeah, I probably would want to do it their way where I have two things it could be rather than one thing. But yeah, their logical screen descriptor. I said it was logical screen and that the logical screen has a color table in it. I don't know, maybe they did the same thing. Let's see. Yeah, looks pretty similar. Gotta admit. So let's see, they have width, height. What did I do? Width and height. GCT flags, yeah. Color index. Wait. Background color index. That's this background color index there. If that's enabled, then we have a goal. So yeah, I did the same thing, right? If this is very similar. So a couple things I noticed is that they have special types for U8 and U16. I have a generic type called unsigned integer, and then the way you tell it how many bits it has is you add a size constraint. Because elsewhere I found it convenient that if you know the size of something, you could place a size constraint. In fact, we could do it here. We can say that this has a size constraint of this times 24. Or times 3. Times 24 because it's in bits. I can do that in my language, and then I would get an error if it didn't parse exactly that many bits. Oh, we have the unknown version thing. I need to fix that. Let's get rid of that. That was just a contrived test, right? There we go. That's cool. I didn't know that there was something else out there that did similar thing. So actually, to make sure that that bounds check actually works here, I would have to like mess it up by like doing something like doing a -1 or something here, right? And that'll be 1 too few. I should get a warning that it didn't parse everything. Let's make sure I get that. I don't see it. Maybe that's broken. Could be broken. It should have given me something similar to like what I was getting, yeah, this skipping extra bits at the end of data. I should have gotten that earlier at the end of global color table. It should have said, hey, wait a minute, you have unparsed bits. Oh, I gotta look into that. Anyway, I'm over explaining things. Let's get rid of that. That's what this colon at the end of things means. Really, it's for built-in types, it's giving the exact number of bits, and for non-built-ins, it's giving a constraint about how many bits should be parsed by that part. You get the point either way, that's fine. Yeah, I have a tendency to over-explain. Sorry about that. If I under-specify it, like if I did it times 23, I think I do get an error here. What's this thing where I have to click that? And anyway, I should have gotten an error. Wait, why come it only went to 490? Oh, because the parsing just ends when you run out of bits. I should have gotten an error or warning about that, though. I don't see it, but maybe it's mixed in here somewhere. I'll just look at all the lines. Problem is the color table's so big. Oh, here it is. Inner bound 11,888 surpasses outer bound 11,880. So that's what you get. You get an error that you use too many bits. So does that mean I would have had I just didn't look for it. If I make that like 25, do I get another error that was just, I didn't see it at first? Actually, I can just, if I do debug level 3, we should see it. Nope, no error. I guess we're allowed to not use all the bits then. Yeah. So it's just an upper bound, it's not a lower bound. Unless maybe, did I have it in my grammar that I could have 2 different bounds? Let me look. See, part of this exercise for me is remembering what I did, because I wrote most of this like years ago and I don't remember all of it. So like there's the bound thing, I think. If the end of the innermost bounded region of input bits is encountered before enough bits can be consumed, an error is published. So I guess I really wasn't concerned about the other way around, right? Where you don't use all the bits in the bounded area. Unless bound has 2 things in it? Bounded region. Bracket expression brace statements. What is this? Oh, this is new. This defines a region of input bits starting at the current position in the input stream and ending after a certain number of bits given the value of an expression. The region must be a proper subset of all regions in the current decomposition context. I don't remember this at all. Bounded region. Left bracket, expression, right bracket, then a brace and a bunch of statements, and then a right brace. I don't remember this at all. But I guess it exists. So that's where I guess this is where I wanted to have a hard constraint, where something has a certain number of bits. Do you know why it was a programming language? It's the format for Bison. It's to be used with Bison in order to generate the source code for it's a parser generator, right? That's what Bison is. So you give this specification to Bison, and I think it's Y, because Bison is the GNU variant of YACC. I think that's the historical context. Yak, right? Yak, yeah. It was called yet another compiler. And so it used, because it's Yak, you use .y files, and then Bison is the GNU variant of that. In fact, they say here, GNU-based Linux distributions include Bison, a forward-compatible Yak replacement. So like if you're really old school, like you'd use Yak, and if you're a little bit old school like me, you'd use Bison. But in general, they're both, yeah, left to right, rightmost derivation, LALR, parser generators, which are pretty old school at this point, right? Like we're talking like 1980s, 1970s tech. Yeah, so that's probably why you're not going to see it a whole lot, because it's kind of old stuff. I don't think you'd use this stuff today, unless you're me. All right. Format. Yeah. Where was I looking here? Oh, right. I was looking at that bound stuff. I forgot that I had this thing called the bounded region. And it kind of got me off track, because bounded region is not a part bound. It's something else. It's like a bounded region of statements. Let me read this again. This defines the region of input bits. The region must be a proper subset of all regions in the current. So it means it can't extend out of the current context. Region is added to the decomposition context before executing the statements defined within the region and removed immediately afterwards. So it's a temporary region. that only exists to put a bound around some statements. If all the input bits are consumed before the last statement, it's an error. Yeah, that makes sense. If after the last statement, if it's still within the region, a warning is published and the remaining bits are just, so okay, so this is if you know the next thing should be a certain number of bits. So we could actually use that. So it's bracket expression then braces. So that would be like, instead of putting a bound here, I would take this expression off and do that like this, right? And then a times, that's a properly, that would be a correct bound specification if I understood my own stuff correctly. Let's see if that worked. We want to see, we don't need the, if I do debug level 3, it should be fine. So I need to get rid of this checking for arguments thing because it's spamming me now. Checking for, we don't need that anymore. Yeah, we don't need this. This was something I added just for debugging, right? So build and run. Cool. So no problem, but I bet if I tweak this now and I made that like 25, so the region is too large, I bet I'll get a warning saying I didn't use all the bits. Yeah, look at that. Skipping 512 extra bits at end of bounded region. Cool. And if I used a number that was too small, I get an error. Inner bound surpasses outer bound. Perfect. So if I have an exactly known size, which this is, right? Then this is sort of an assert saying that this had better be exactly this number of bits. And maybe there was a way to do it with the other syntax, but I just don't remember. We're going to continue looking for that because I got to remember this stuff. I need to understand this stuff before I port this to Rust, right? So optional bounds is a colon followed by an expression. It looks like it's just a single, if it's a single expression, then it's just the outer bound. So if I wanted to alter this, I would maybe have expression and then optional other expression. And then you can either have 1 or 2. And if you had 2, then you're specifying both inner and outer, right? Or upper and lower. And if you only had 1, then maybe it's just an upper bound or something like that. Yeah, I think that the bounded part is, yeah, this bound is only used for checking the upper. I can actually search for that bound, right? So here we go. Actually, we can completely just search for all references to that and we'll see it. Okay. That's when, why would evaluate an expression give have a bound? Wait, the bound. Oh, that's evaluating a bound expression. Okay, never mind. Yes, we want to evaluate that thing. Okay. All right, so if there is a bound, then we figure out what it is, make sure it's not negative. Right, so here's where we check. It has to be the inner bound. If the inner bound can't be larger than the outer bound, otherwise we blew the box, right? We exceeded the number of bits we were allowed. But there's no check for the other direction. There is this limit though. What is that? There's an ignore limit. I wonder if I can if we use that somewhere. What's ignore? Statement ignore. There's an ignore statement? Huh. Oh, I remember this. There are certain formats I wanted to parse where I just wanted to skip some like reserved bits and I didn't want them to show up in the report. So I made a syntax for that called ignore. Yeah, ignore specification. It's like a part specification except where all the bits are dropped, no components added to represent them. It's used for things like reserved bits or to skip. See, I remembered this. I remembered it. But that's not what I was looking for, right? That's the bound statement. Okay, when we generate the report, we print it. I guess that's all we use it for. We just make sure we don't exceed a certain number of bits. Oh, there's probably one other place where we'll see it used, right? That's in the UI elemental. We have these things called elementals, right? If I just look for UI, we'll find it. Here it is. I bet in here we use the bound. Okay, it comes across as limit for some reason. Oh, that's the limit. That's the number of bits remaining, right? Oh, look at this. I wrote myself a comment. Number of bits left in the innermost bounded region containing this component. Cool. So it's checking to make sure that we have enough bits, right? Oh, right. Because it's initialized to be the bound. So it becomes the exact size. Right. And then, so we read that many bits. Okay, that's cool. So this limit is set to the bound when we start. So yeah, that means that when I do stuff like this, that this bound becomes the limit for this part. Parser for what? Right now it's GIF. But I am making this parser very generic. It will parse anything as long as you give it a format specification written in this special domain-specific language, which we learned today is similar to IMHEX, which I knew nothing about, but I made this a couple of, more than a couple, like 5 years ago. And yeah, I'm testing it with the GIF, GIF or GIF, however you want to say it. I've been saying GIF to piss off both camps, but you get the idea. It's a format that we can easily look up what it should be from the specification made in 1989, right? That looks like here. So just from their grammar, I was able to like kind of translate that into my DSL, and I'm not fully specifying everything because there's some stuff that I want to have that I'm missing, but I'm doing enough of it to like make sure my parser is working. And my plan is to take this parser and port it to Rust. Isaac Newton invented calculus independently to some other guy. Yeah, it's true. Sometimes you'll find 3 different people invented it. One person invented it, and then the government or the church at the time burned them at the stake, and so it was lost. And then 200 years later, 2 more people independently invented the same thing. I invented a parsing DSL indecently too. Indecently? Oh, independently. Yeah. Okay, that's better. Yeah, my DSL is described in Yak/Bison grammar. So it looks like, skipping the boilerplate, it kind of looks like this. It's a sequence of format specifications, and a format is identifier optional arguments, a brace with statements. So it kind of looks like this. This is one without arguments, and here's one with arguments. The arguments part was broken this morning, and I fixed it today. So that's good. I'm actually finding things that were broken, and I'm able to fix them. I was talking about this earlier. One thing I really like about this is that the format specification looks like a function when we start, and at the end, it generates a structure that matches the flow of the function. So output of this is going to be 3 arrays, red, green, and blue, because we defined red, green, and blue within the context of a loop. A loop turns into an array, where the array holds the value of the part specification at each step of the loop. Yeah. Okay, so I tested the fix for that, and then I tested the fix for free function, which was here, right? This name ends up here, and so this works, and then this ends up being put back here, and it works. So then what's the next thing I want to do? It'd be really cool if I could have this look ahead function, but that might be too hard for me to do tonight. Maybe I go parse it a little bit deeper. We'll look at the spec, maybe what's next after the color table. So that's the end of logical screen. I guess the next part would be data. And here's where we have to kind of like, I would like to do the look ahead, because trailer terminates the sequence of data blocks. And so we don't know if the next thing is a trailer or a data until we look ahead and look at the next byte, because a trailer is always, do I have that coded up here? Yeah, it's always going to be a 3B. Actually, we can have this test here, right? If label is not equal to that, whoops, then we're going to say an error. What are we going to say for the error? Expected trailer here. So you can kind of guess that we only want to declare a trailer if we know that we're going to see a 3B, right? Well, it'd be nice to be able to say, look ahead 8 bits, and if it is a 3B, it's a break out of our loop and declare a trailer, right? But the problem is that this function I can't specify right now. Every function I can specify parses something. This is a special function, so it needs to be a built-in, which does a look ahead 8 bits and generates a value from it. So I could try to write that function now, maybe. If I could do that, it would be great, because then I could specify it the way I want to. The alternative is I was going to have this like infinite loop where we parse the first byte, and if it's 3B, then we call trailer, but we kind of tell it that, hey, yeah, sorry, we already parsed your label, so you don't need to do anything. I'd really like it to be this, because then the specification would really closely match this grammar. So I'm really tempted to like go for it and do that. Should I? Kind of feel like I should. Okay, yeah, let's do it. I probably won't get this working tonight, but we'll get somewhere. This is what we really want, right? We want to say that a GIF file is a header logical screen, and then we have some data blocks, and then we have a trailer. Then we completely specified what the header is. It's gotta have GIF. So this is over specified. Maybe we can reduce this now, because that was contrived just to test something, right? So we don't need that anymore. So this is fully specified. There's this 24-bit signature interpreted as a string. It needs to be GIF or else it's bagged signature. Then we have a version number. I think we wanted to have a test here. If version number is not, come on. If version number is not 87A and it's not 89A, those are the only two legal versions currently, right? Then we'll say it's an unknown version, I think. Unknown version. Okay. Okay, let's make sure that that actually works. Cool. So it got down to where it doesn't know what the format look means. That's great. If I do a 2, we can actually see it parse all the way through the global color table before it got there. It's parsing the version number correctly. These all look great, right? Cool. Awesome. So then this should work down to where I didn't fully specify data yet. It's to do. Oh, we didn't fill in the image descriptor either. Oh, right. And then there's this other bug. I think I had that as a to-do item, right? Okay, I know why we don't get a warning if we don't use all the bits. So how do what's the shortcut for to do plus to mark it done? Toggle, that's Alt D. Alt D, there we go. So I do know why it's done, but I kind of want to say like, maybe generate a warning. It's either generate a warning if a part doesn't use all the bits in the bound, or offer make a way, I guess, to specify both an upper and a lower bound. Okay, and then, right. We fixed that. Ta-da. Figure out why energy, okay, so that is an error. That's a bug. I need to fix that. Do I want to fix that now or to fix it later? I don't know. This is something that would be nice to have. This is, so I guess it's either I should do that or I should do one of these other bug fixes, right? The order of operations one kind of bothers me. This one bothers me more because that should work. I don't know why that's not working. I kind of want to fix this one. So maybe I do that one first. Then I do the look ahead function. All right. So let's illustrate that problem. That was here, and that's when I did that. I didn't mean to have all this stuff actually. Why did I do it that way? Yeah, anyway, the problem is that I don't have a GIF file that actually has an aspect ratio in it. So I was doing was I was commenting that out and just pretending that a 0 actually meant something. And then I would try to parse it. And right, I'd get this oh, encoding's not found. Oh, because we don't want to comment that one out. Yeah, I'd get this unable to apply binary operation on values 15 and 64. So like that should not be an error. So I'd like to figure that out because internally before it does the divide, it should be like promoting these two to be the same type. Auto promotion. So let me find out where that can be found. Oh, that didn't work. Do this without, yeah, let's do it again. Unable to apply binary operation. How come I can't? Oh, that's right. Copy in the terminal is weird. It's like a shift control C. Here it works. Okay, here's where we should see the error. It's if, wait a second. It's here. It's if we do a binary operation and we get a null pointer as our answer. That we shouldn't see because this should know how to do, oh wait, why is this null? Oh, this is the base class, I guess? Because right-hand side is a value and value is a base class. Right. But the there should be a value double or value decimal, right? Value decimal. And it should declare the, yeah, here we go. The binary operation for a value decimal. So there should be a divide here somewhere. Oh, wait. Maybe it's this. If left-hand side is not integer? Oh, this is a bug. This shouldn't be here. This must be a copy-paste bug. I bet you that got copied from value integer. I bet you that's what happened. Oh, yeah, look at that. It's a copy-paste bug. This should be type decimal. Right? And does this even make sense? What's OR again? Logical OR. Okay, so logical OR does kind of imply that we want to test for, yeah, truth. Test for truth. So this is correct, right? I don't have a value by a Boolean. I just use integer, right? And I just store, I just do a coercion, implicit typecast to an integer. So this will be a 1 for true, 0 for false, right? So that's a bug. That was a bug. Now I fixed it. Maybe that's all I need to do. See if that did it. No, I didn't build it. Building is important. Build and then run. Okay, that was it. Fixed 2 bugs. Sweet. So yeah, there we go. Aspect ratio of 0.234. Okay, let me clean up the hack that I did. I'm glad I fixed that. I must never have tested dividing decimal numbers before. So it does coerce this to a decimal. It's just when it divided, for some reason, it needed that to be an integer, not a decimal, which is backwards because it was a copy paste bug in here. That was copied from here, right? And I just didn't change it to decimal. Let me look, just glance to see if there's other places they copy pasted. So yeah, less than, it should be integer because again, I don't have a value Boolean. So things that will yield a Boolean should be an integer, but like subtraction should be decimal, add is a decimal, divide's a decimal. We check for 0 divide, and mod multiplies. Okay, those are all good. Okay. Cool. So we're good there. Let's close these guys up. So I can go back to my to-do list, mark that done. I'm wondering, should I like have a report here about why? Let's do it. This was because of a copy paste bug. There is a check to make sure the other side of the expression, other side of the operation, the other operand, right? The upper operand is of the same type. By the way, if they aren't at first, there is a type coercion. How do you spell coercion? Coercion? I can never remember how to spell. I always have to look it up. Coercion. Okay, is it with a C? Okay, I always forget that. It's not an S, it's a C. There is type coercion performed before we get to the actual operation. There's a check to make sure the other operand is of the same type. Because I copied the integer code to make the decimal code, the decimal code was expecting an integer for the other operand when it should expect a decimal. All right. And then I had another note where I had a question, right? Whenever I have these questions, I figure out why I should have a follow-up. Why did we get a warning when we don't use all the bits? Because the bound on bounded, really this should be format, right? A part. Because the bound on a bounded part is an upper bound only. There is not yet, anyway, any lower bound check. Although, well, however, there is an alternative syntax to do a similar thing. Bounded statement. Okay. Which we figured out, and I ended up using that because that was kind of a cool thing that I realized I had forgotten that I did. This is a bounded statement. It says that this part needs to be exactly this number of bits. If it's not, we'll get a warning or an error. A warning if we use too few, an error if we use too many. This is an upper bound only. This is a stricter bound, and it applies to a group of statements. That's why it's kind of like an alternative that's not exactly what I wanted. What I really wanted was to like say that this part alone, so like on the same line, needs to be like exactly this limit, both upper and lower. But that's not how it is right now. Anyway, back to this. So So we figured that out. So then I guess it's time to either look at look-ahead functions or figure out why this was wrong. I wonder if this will be quick. This is just an order of operations thing, right? Yeah, let's look at this. So then that's in the grammar, right? So the abstract syntax tree that's generated should do the add first. And that was done down here somewhere. Yeah, where exactly? Not there. It was somewhere else. Or was it there? No, it's not there. Here, right? I shouldn't have to have these extra parentheses. Actually, do I need those parentheses at all? Let's see if that works. Okay, I don't need that one. But the problem is if I do that, that should work, right? Because it should do that first and then add. But I think the problem is it's doing that first and then shifting. So we were getting like crazy numbers. Yeah, we're getting these crazy numbers, right? That's what we get if we actually take the most significant byte and left shifted 8 plus the value of the least significant byte, which is 1. So that's 44 shifted left by 9 would get us this, I think. That's actually not correct. Oh, no, it's 1 shifted left 8 plus 44. So that's 52. 1 shift left 52 is probably that, right? So yeah, order of operations is wrong, and I wanted to fix that. Question is, do I see that when I look at the format? For parse format? Let's see. Actually, let's make another terminal because I want to be in the other directory. I want to be in build VS Code parse format. And run that, and then where did I put it? 2 levels up stage GIF or GIF.format. Okay. What happened? What happened? I accidentally killed my shell. When you misclick, you kill things, you know, it's not cool. Okay. Do this again. Stage.gif.format. Okay, here we go. So this should give me a abstract syntax tree of the entire grammar file, right? Right, so what do I get up here? Where was it actually? Right here. Yeah, see how it grouped it? It didn't group it right. Compare that to what I actually wrote, right? It actually grouped it right to left. Or it thought that this was higher precedence. It thought that this was higher precedence, right? Is that how you say it? So it needs to be the other way around. So the test will be I run this parse format and it should group them differently if I do it correctly. Let me make sure that that's actually the bug by flipping these two operators. If I put the plus there and the left shift there, do I get different results? I do, right? So it's still doing, it wants to do the add first before the left shift. So I must have them backwards somewhere. And that's a grammar problem, right? Oh, I didn't want to have parentheses. I need to run that test again. So that's that, but then if I do plus that, it'll move the parentheses around, right? Yeah, okay. Just checking. Okay, so put it back the way it was. It should be left shift 8 plus that. And the parentheses should be around these two, not these two. Okay, let's fix it then. So guessing it is my grammar file. Let's look at the grammar file and try to figure this out. So it would be an expression somewhere, right? Expression. expression. Is it in the order in which we describe these? So maybe, do I need to like put shift above? So here's left shift, right? Logical or, logical and, inclusive, exclusive, max, in, not, flip, minus, parentheses, function call. Okay, so where's the add? Okay, that's up here. Expressions are valued from innermost outward, and the result is the literal value, right? So I probably put the parentheses at the very bottom, right? Copy? Wait, am I looking at the right thing? Yeah, that's all expression, right? Yeah. So where's the parentheses? Here it is. Group to disambiguate or override operator precedence. Oh, here's an explicit precedence thing, right? Yeah. Hold on. Do we specify operator precedence here, or do we do it in the lexer? Maybe we do it here. Supposed to do it here, maybe? Or actually, I'm starting to think it was done somewhere else. Is that somewhere like else within the parser? I think it might be here somewhere. Is it up here? Token. Oh, here it is. I think it's actually the order in which we do this, right? So where's left shift? Here it is. Yeah, what if I move this line down to here, right? Isn't that correct? That'll probably fix it, right? So build this again. Terminal, run this again. Yep, that fixed it. Now it's that. So, right, if I flip the order, build again. Now it's the other way. So that's all it was. So this is in the order. That means, just talking to myself here, we specify the operators when we say left and right. It's always in the order of like lowest to highest precedence, right? So we do the bind, like the loosest at the top is comma, and then assignment, and then or, and then and then in, and then inclusive or, exclusive or, mask, and then equal and not equal to are the same precedence. These are same precedence. Does that make sense here? Yeah, so you'd have like A less than B equal to B less than C. I think that's correct. Hey there, toggle bit. I just fixed a bug in my parser. That's the bug. Do you see it? Have you ever worked with parser generators and compilers? I'm doing great. How are you? We should give a shout out to Toggle Bitty. You should watch Togglebit. Extremely fun stream to watch. You haven't used parser generators before? They're pretty neat, but they're also pretty old school. So I'm using Bison, which is a GNU tool from like the 70s, and Flex. So Flex is what I use to generate the lexer. That's where we like define our reserved words. And we give patterns for input text to generate tokens. So this is what our identifier looks like, right? An alpha followed by 0 or more alphanumerics. And then like, it gets really fun when you talk about floating point literals and all that stuff, hexadecimal literals. It really gets fun when you talk about strings, because when you're parsing a string, you follow different rules, right? When you're inside those double quotes, everything means something different, and it gets really complicated when you're talking about escape characters. But yeah, it's a bunch of pattern rules, definitions for literals and operators, and then a bunch of boilerplate, right? Like this stuff. And then that turns our input characters into tokens, and then the tokens are used to form semantic meaning when they're in a string. We give semantic meaning to what they mean if they're in a certain configuration, and that's what a parser helps you do. A parser defines syntactic rules. It says that our format specification is going to be one of these, either nothing at all, or something illegal, or a chain, which is a recursive definition, which is pretty sneaky, because the first one is always going to be empty followed by a non-empty one, and then the second one is going to be one format, and then the second one, and then the third is going to be two formats followed by the third one, and so on, right? Yeah, so Bison or Yak generates a parser based off of grammatical specifications that leverage those tokens, right? So your characters come into the Lexer turns them into a stream of tokens, and the tokens have to are scanned, and then they like match grammatical rules, and that's how it generates the compiler based off of matching input tokens and then running through code when it matches things. So whenever we match a format, we call a callback called emit format, and we can recognize one kind of format is, and if we scan ahead and we see exactly this sequence: an identifier, optional argument list, left brace, some statements, and a right brace. Then if we match that, then we go into this code, and the code is basically saying create a format. The identifier is the name of the format. The statements are bound to that format along with the arguments, and then the special token $$ is just like the data associated with the what that is reduced to. It's reduced to whatever this is, which in this case is a format. Looks like very complicated for strings. Yeah, the Lexer rules for strings are it's fine until you get into escape characters. Then it's like, well, there are certain literal characters that mean something, like A means alarm, B is backspace, F is form feed, N is new line, R is carriage return, T is tab, all that stuff, right? Because I picked the same escape characters that exist in C, it's a one-to-one mapping. But I didn't have to do that. I could have made my own crazy character sequences that mean something different in C. But I don't want to be that insane. I just matched them one-to-one. I probably could have made a macro to do this, but I hate macros. Also, some of them aren't exactly the same. So like \x goes into a special state where we're looking for hex digits, right? We can have one or more hex digits, and every time we see a hex digit, we're going to shift left by 4 and add something. Where does that happen? It should happen somewhere. I don't see it. It's this code, right? Oh, is that because it goes into right, because it's always a 2-digit thing? Is that right? No, okay. I don't remember why we have state 4 and 5. Oh, it must be that this is for the first hex digit, and then this is for the subsequent hex digits. Right, because the code is different. The first time we don't multiply by 16, we just assign. The second time and subsequent, we multiply by 16 and then add. I guess I could have collapsed these together by just initializing the code to 0 and then doing this. Yeah, or whatever. But yeah, it gets complicated because you really have to have a state machine to parse some of this stuff, right? Because, right, when you see the backslash, you don't yet know, is the backslash going to be just a single character, or is it going to be like an X? And then that means there's going to be like some hex digits that follow that. And like, yeah, it gets really like, and here's like for an octal sequence, right? I think that's why I have 6 different states. It's either single character, it's the first digit of an octal sequence, it's the non-first or the second octal character, and the same thing for hex. and the default is it's not an escaped character unless you see a backslash, and then the next one's an escape character. And then you see these LLY vowels, that's just like a secret lingo that the it's like the glue that goes between the lexer and the parser. They exchange these like attached data for every symbol, and that's what these S's and other things like. You declare the type of data that's associated with a symbol somewhere here. I think maybe we declare it inside the format. Yeah, here it is. So you declare it as a union. You say, well, here are all of the data types that you could have attached to a symbol. And so S is if it's a string, right? So somewhere I have it specified that for the string token, we want the S field attached to it. So we're always filling that S field in when we're building a string. So somewhere in here, there's going to be a attachment between, actually I think it's in the lexer, in the parser. Somewhere here there'll be an attachment between the word string and the type S. Here it is. That's where it is. So yeah, I kind of like Bison and Flex, but I'm open to new ways of making compilers. This is just how I did it in C and C++ years ago, and I'm getting refreshed on it because I'm preparing to port this to Rust. All right, and now that I've over-explained everything, no one's watching me anymore, right? Let me go back to my to-do list. Okay, we fixed that. That we fixed. So mark that done. Okay, the problem was I accidentally ranked the shift operator below the add, subtract, multiply, divide operators. And that's when we kind of got sidetracked talking about what I was doing, right? Because we found out that that's specified in the parser, right here. So this has a double meaning in that we're defining what our operators are, and we're also, actually it's got three meanings. We're defining which things are our operators, and then we're saying whether they're right or left associative, and I won't go into what that means. You can look it up if you want. But we're also, by the order in which we're listing them, we're saying what the operator precedence is. Like, which, if you had A operator, B operator, C, do you do the A and the B first, or do you do the B and the C first? Right? That's the order of operations. What part am I porting to Rust? The entire thing. The entire thing. Right now, it's all in C and C++. And I do have some GUI elements in C# and in Cocoa, or Objective-C, and they are broken. I want this to run on Linux too, so we got to get this going on Rust, right? There's no other way. So I've gotten leads on what I could use for the alternatives for the parser and lexer, but first I want to understand how the existing parser works, and how the parser, the problem is the word parser is overloaded here. There's the parsing of my domain-specific language that looks like this, right? This is my DSL. So it's the parsing of this, and then once that's parsed, now we're going to use that to parse binary data, in this case a GIF, right? So the parser of my language is what I call the formatting, which is what we're fixing. It's basically the Bison Flex stuff, and then the types associated with it. It's actually pretty small. And then the actual parser that uses this DSL to parse like GIF data, if you gave it that spec, I call that the parser, and that's or the decomposer, and that's in this decomposition library. And that's where I had that's mostly the C++ part. That's not Bison and Flex. It walks the DSL that is built from this this domain specific, not the DSL, the abstract syntax tree, right? The compiled version of this is in memory, and then we use that to parse the data. And the way that works is at the very top, I think, where would it be? Decompose. No, even higher than that. Would it be in the constructor somewhere here? Oh, I think the way it works is you have to give it a... It's in the outer class. You have to give it like a context. Yeah, there's a decomposition context. And in that context, there is a pointer to the actual data somewhere. Oh, maybe it's not here. So where did I put that? There's like a pointer to the actual data somewhere. I forget where that is. I don't know. Somewhere around here. Maybe the bottom of the file, maybe the top of the file. Who knows? This is the problem with this old code I haven't looked at in years. I don't remember. I don't remember how this worked. Here's where our built-in functions are, by the way. Somewhere here, we're going to be given the actual data pointer. Where is that? It's not here. I thought it was in this decomposition context, but I'm looking here. Maybe it's inside of component? Oh, here it is. The object that provides the bits. The bit stream. That's right. I made this library, and then there's an app that uses the library. And then that app was called Decompose. And it's just a main program, and I think it just implements the bit stream, right? Maybe not. We'll find it here, right? This is the very top level of the program. So at some point, like here's our usage. Here's where we compile the specifications for the data format. Okay, here we go. It's this bitstream file. We open it, and it's like, it's a bitstream, but it also reads a file, right? So read, here we go. Read will look at a cache if we already have bits, but if it runs out, somewhere in here, right here. If it runs out of bits, it goes to the file and reads more. And that I have Windows and POSIX implementations. POSIX implementation just calls read. Hey there, Stripe Monkey. How are you doing? I don't know if you've noticed, but I'm streaming at a different time right now, and that's because I ran out of time this morning and I was in the middle of a problem. I really wanted to solve it, so this is like a bonus stream. Normally, I wouldn't have started my stream until like roughly 10 hours from now. Perfect streaming time for you? Well, then I will have to start doing more extra streams. It's usually the other way around, right? Usually, when I'm like beginning my stream, you're ending yours or something like that, right? You hop on in about 3 hours from now, yeah. And then you're like, you go for a long time. Basically, while I'm asleep, you're working. And then by the time you're done, I'm just about ready to start. And sometimes you're still going when I have to go to work, and I'm actually able to raid you, but that's very infrequently, right? Yeah, so here's like the very low level stuff where we're actually reading a file and we're putting it into a cache, because I have to deal with reading fields that aren't exactly aligned to 8 bits, right? So like when we read these flags here, this is 1 bit, color resolution is only 3 bits wide. So when we read this, we're like misaligned on purpose. It even says so in the spec. They have a funny way of documenting that, right? They have like they use these little old school block diagrams, right? And they'll do packed fields, see below. And they say, well, we have 3 bits followed by 3 bits followed by 1 bit. And they actually have that. You can kind of see it. That's 3, and that's 1 bit and 1 bit. You did notice it's quite late? Yep. All right. Back to my to-do. So we fixed that. So then I think that's minor. We already auto-coerce when we need to, right? This one I'd really like to have, because until I have that, this is not going to work. When I try this, I get in the other window. I need to do this with the D3, right? Yeah, I get unknown format look. So the idea here is, because the grammar in the GIF specification says 0 or more data blocks followed by a trailer, and the only way you can tell the difference between a data and a trailer is by looking ahead 8 bits and seeing if it's the byte 3B, which, did you know, all GIF files end in 3B. You didn't know that before, and now you do. So yeah, we have to look ahead 1 byte and see if it's 3B, then it is a trailer, right? So the way I thought that the most elegant way would be, we have a while loop, we look ahead 8 bits every time. If it's not 3B, we parse the next bits as data. And if it is 3B, we'll break out of the loop, and then we'll be reading the trailer, and we'll have another double check in trailer to make sure it's a trailer. Edumacational, exactly. Now you know. Now you can go into any other stream and you can say, haha, did you know all GIFs end in 3B? Okay, I didn't fully specify data yet. It's to do, and I think I left off here an image descriptor, but that's okay. I want the look ahead to work first. So I think the way I want to do this is just like I have these built-in functions for string and bit and unsigned integer. I think I want to have look be a built-in function, which instead of parsing and instead of being a free pure function, it actually cheats and looks ahead 8 bits in the bit stream and then rewinds it and returns you what the value is, and as if it hasn't been parsed yet. I think that's how I want to do it. Question is it always going to be an integer? Or do I want to like have like a look ahead int, look ahead string, look ahead bit, that kind of thing? Or maybe what we do is we say like, maybe it's a special syntax. Maybe it would be like this. It would be like while 1. We would have like local next, and we would say next equal we would say like look 8. How would I specify this? It would be not look, but it'd be like, actually it would just be like next, right? It would be like UI next is 8, but then if I want to specify that it's a look ahead, maybe I would do something like bracket 8. Ooh, it's not actually a bound now, it's a look ahead of 8 bits. Actually, it's both a bound and a look ahead, so maybe that's not the best way to do it. What would be like, what if I put the whole thing in brackets? Problem is, I think with that is I already have that here. That means something else. What would look obvious that it's a look ahead? It's like a typed look ahead. This is an untyped look ahead where it's always integer. This would be like a typed look ahead, but how would I specify that? What if I had like a star in front? Then it's a look ahead. Or how about a plus? Ooh, there's an idea. Then it's like, if we see a plus, then we're going to parse that as if we were parsing, but then end up rewinding when we're done. But we'd still assign a value to that. Right? And if I didn't want to give that a name, I think there's a way to do that, but I'm not going to worry about that. Yeah, so the idea would be turn this into an if. next is not equal to 3b, or actually if it is equal to 3b, then I think I have a break like that, right? So that's an alternative syntax where I don't use a function, I just have a new rule in my grammar, and that marks it as, after parsing that, rewind. That might be the easiest, because then I can leverage the existing code which does all the parsing, and just if that's present, then we know that when we're done we want to rewind. So maybe that's what I do. Yeah, I think I like that. So right now it's not going to parse correctly, right? It's going to look at that plus and say, I don't know what the heck you mean, Raimu. You're going to have to try that again. Yeah, it's going to say syntax error, right? But what if we altered our syntax and made a rule for it? So that would be to alternate parts. Actually, we can build it into the current part specification. This way, we can have an op look ahead. Aha, op look ahead. And then we're going to need a name to associate with that because we need to actually store it in there somewhere. So let's call it look ahead. Okay, and then we're going to want to store it somewhere. So let's just assume we're going to have something called look ahead. And we're going to assign it to the value of look ahead. All right. So now we have to actually define that grammar somewhere else. So where am I going to do that? Probably the next rule. Can do it here, right? Okay. How much time do I got? I got to go to bed soon. Maybe in 15 minutes, 30 minutes. I probably have enough time to do this, right? I'm always positive, right? Optional flag to indicate a look ahead part. We rewind the stream. Hey, try catch TV. How are you? Thank you for the raid. Hope you had a great stream. Hola. We rewind the stream afterwards. Let me know if you're interested in what I'm doing. If you haven't been looking ahead to see what I'm streaming, I can describe what I'm doing. Is that how I do multi? Yeah, that is how I'm doing. I'm trying to keep the same style that I started with. Just a brief summary. I have this tool called the DataDisintegrator, which, if you specify a format like GIF or GIF, you know, this pretty much matches what the official GIF specification says how you would parse such a thing. And you had a GIF. Actually, I need to close that. There's this bug in the binary editor here where the scroll bar never goes up to the top. And I just noticed that this morning and it's annoying. Anyway, we have this GIF file. It's a POG slide or lol slide or whatever. And if we open it with a binary editor, it looks like this. So the point of our program is to take this sequence of bytes and parse it, basically figure out what's in it. Based off of the specification of that file format, I express it in the form that looks like this, which is a language that I invented, which is kind of like a combination between structures and functions. So a GIF file is like, structurally it is something, it's the file, right? And inside the file there's a header, and then there are blocks of data, and there's a trailer, all that, such a thing. But it's also a function because we have loops and we have if statements, right? And you can kind of see the same thing in the spec, right? When they have the star and they say the star means there's like repeat any number of times, right? The word repeat kind of implies that there's a loop, right? So in a kind of way, they're also describing a data structure in terms of a function, an imperative function, right? It's like one statement after another. And basically my program is two pieces. One piece compiles this special syntax, and the other piece takes the compiled specification and applies it to the data, in this case, our lol GIF, right? And then spits out what was in it. So literally we get, well, I can't show you right now because I have a syntax error, but hold on. Let me undo the syntax error and show you. So it'll say, well, yeah, hey, look, the signature was GIF. The version's 89A. The, I don't know why this is so stretched out now. It wasn't like this before. Anyway, the width is, oh, yeah, that's still broken. Oh, I forgot to build it again, right? Let me build it. Build the decompose. Build. Oh, I can't build it because that's broken. Okay, never mind. Pretend that it's actually saying the correct thing and not a garbage value, but you get the point, right? So the parser, it's not like it shows the GIF image, but it does the first step in showing you the image. It's taking the raw bytes that were in the file. You know, if you recall this, it's taking these raw bytes and like figuring out what the bytes mean. So the first 3 bytes is the signature, next 3 bytes after that, right here is the version number, and then following that we have like the things that are harder to see, like the how wide and tall it was, the global color table, and then the data blocks and all that stuff. If you were to actually make a something that would show the GIF as an image on the screen, you'd have to take those parsed values and actually do something with it. In this case, it would be like build an image pixel by pixel and then copy it to the screen. I'm just using GIF as an example format. My tool should work with any binary format as long as you can specify it in my language. Okay, so going on. I wanted to make a new syntax to say, look ahead 8 bits, and if it is 3B, break out because it's a trailer. So that's the point at which we got rated, right? So here we go. Look ahead can be empty, in which case it's kind of like this, right? So it's either empty or it's a plus, right? So plus, and in this case, it's actually, I think what I want to do is I want to assign values to this. It's either 0 or 1. So we're going to have to say that the type of look ahead is a number. Is there a way I can do that here? I mean, is there a way I've done this elsewhere? Like, what is optional bound? How does that work? Oh, it uses expression. In this case, I actually want it to be a flag. So how do I do that? It's actually something I haven't done before, right? Would I use I? I guess I'd use I. So actually, let's do it here. So it would be type I op look ahead. There we go. So I get it the type integer. So something else of type integer is integer. And I think that would work because we can now assign to it. It's either 0 or 1, right? It's either empty or it's there. Okay, I don't remember if I'm supposed to put the literal plus or put plus there. I think we put the literal plus. Just kind of looking at the convention of how I did things in the past. Where would I see tokens like that? I guess it would be like right here. It's the closest I get to it, I think. Okay, then I don't want it to say just plus. I want to say like it's either empty or it's literal plus. Right? Now plus is a symbol, right? Yeah, there it is. Okay. So if we see a literal plus, it's a 1. Okay. Then where we use it, right? This look ahead needs to be an integer inside of statement. So that's statement body. Okay. Body, don't do that. Go up. Statement. Okay. Where do we define statement? Forget how this actually works. Oh, right. That's a reference to the union that I have declared up here, right? There's a union up here somewhere. Yeah, here. Right. I for int 64t statement for that struct. So we need to look for that struct. I probably have it in a file by itself. Yeah, I do. Here we go. Okay, found it. So then, yeah, we just need to add to this. Anyway, I guess it doesn't matter where. I probably should put it here. Yeah. If, actually, why am I typing it when I just copy all this? If the statement is of type part, this indicates whether or not the part is a look ahead or something that after we parse it, we rewind the stream, rewind the bit stream back to back to the beginning of the part. There we go. Okay, so that would be we can use bool here, right? Actually, it's C. There's no bools in C, right? There's no bools in C. Actually, maybe there is a bool. Can we use bool? I'd like to use bool. Look ahead. Then I need to make sure I initialize that. So let me look to see where do we initialize like loop var. Would it be in create statement? Yeah, maybe. Well, we mem set it to 0, so it's probably fine. That means by default it's not a look ahead, which is correct. Okay, so then I don't need to do anything. This should just build, right? No, we have an error. Let's see where that error is. Okay, it doesn't know what a bool is, so okay. I guess I'm not using a new enough C to define what bool means, so we'll use int. That's the old school boolean, right? Build that. Alrighty, so we built, but I bet when we run it, it's not gonna work. So, in fact, I think it's gonna get into an infinite loop. Let's see what happens. Syntax error. On line 2? Oh, shoot. It can't look ahead enough to see if this should be a... I think, yeah, it can't look ahead far enough to see it. Yeah, this is the problem with grammars. This is sometimes like you can't specify them the way you want. It's either that or I made a mistake here. Yeah, I think this putting this here is a problem. Well, if I put it like to the right of identifier, maybe it would work. So like, let's see if that works. So I put it to the right of identifier, right? Then I just need to change this to put the plus to the right of the UI. Like that, right? maybe now it'll work. Let's see, build, and then run it. Okay, now it works. Cool. So we can't put the plus in front, but we can put it on to the right of it. That's fine. So whenever we see a plus after the identifier, we'll know that it's a look ahead. I think the problem is you can't really have the first thing be an optional thing because it can't the scanner can't really look that far ahead. You need to like have the first thing be a non-optional thing. Is that where I want it to be? I think so. I think so. Okay, so we're good. So then it's not actually going to look ahead, right? Oh, it actually is looking ahead. Well, it's sort of looking ahead, except that's 3B in decimal, right? It didn't rewind, so the next byte is at a different offset and doesn't match the trailer. So yeah, okay. So that's a great test. If this is implemented correctly, then it would end up infinite looping because I think data is empty, right? Data is not going to parse anything, so we're going to end up in an infinite loop. So let's maybe put a dummy thing here. So dummy, and the type is unsigned integer, so it should parse something now. Yeah, so then that's fine. It's just that it should not, the next should not advance a byte. It should just look ahead a byte. So that's now we can actually implement that. So okay, let's try to implement that. That is in decomposer, right? When we're actually decomposing a component which has, okay, it actually has to find the format, right? Where does it do that? Here, right? It finds the format here. So this format, right? Here. Okay, so go ahead. All right. We had someone retrieving something behind the green screen that you couldn't see. So this, so format. Oh, right. It's not part of the format. It's part of the part specification. So I'm looking in the wrong spot. Format is, in this case, it's UI, right? But we want it from the whole statement. So where is that? So that's somewhere else, right? That's in execute statement, right? Here we go, for a part, right? So we get a part reference and we look it up to find the statements. Actually, here we go. The statement is given to us, and the statement has the where is it? Way down here we added look ahead, right? So if look ahead is in statement, then I think what I want to do then is it's only used for a part, which is right here. So when we actually call decompose, we need to pass that look right here. Here's where we need to pass it, right? Yeah, this is it. So either I need to pass it to decompose or I need to put it in the context of decompose. So what's better? Actually, I think it should be just an argument to decompose because it's only that outer call that we'll need to rewind, right? So yeah, that means we're adding another value. So it'd be state meant look ahead. Statements not defined. Too many arguments in call. Right, well, we can fix that. So decompose will have like bool look ahead equals false. Yeah. So then go back, and this should be like if it's not equal to 0. Turning an integer into a Boolean in the polite way. So let's build that. Cool. All right. So now decompose knows whether or not it's a look ahead. Let me document that. So someone yesterday was actually asking me this. What do I think about documenting ahead, or like documenting as you go? And I think in C++ we have to do it at the function level at least. And that's already helped me this week, because as I'm looking over this old code, not understanding what the heck I'm doing, at least I can look at these block comments and kind of get some hint about what we're doing. So here, what does look ahead mean? If this is true, rewind the bitstream after we finish parsing. Finish decomposing. Rewind the stream to the point it was at when, if this is true, on exit, how do we want to word this? Look ahead. If, we don't have to say if true. If true, rewind the bit stream on exit to the point it was at on entry. Does that make sense? If true, rewind the bit stream on exit to the point it was at on entry. Okay, cool. I like that. Okay, so then that means like we kind of have to like record where the bitstream was at the beginning, and then like be able to tell a bitstream to go back and rewind to a previous point, right? So that means I probably need to update the bitstream interface, because I don't think it supports that right now. Okay, so that's where the bitstream actually is. Oh, right, it could be null. So what do we do if it's null? I guess we don't do anything, right? We do have a set read offset. It's just that we can't go back, right? Oh, we can. We can just rewind it. Well, that's awesome. That's great. So it just is set position. So that means we can rewind it. Great. So that means that all we need to do is record the current offset at the very beginning, right? Where do we get that offset? Well, can I just ask it what it is? So we can say like, in fact, this is the perfect place to put it. We can do it here. We can say if look ahead, then it's actually if look ahead and the component bitstream is not null, then we need to record the current offset. I don't think we can trust this offset though, right? The first bit, which makes, so I don't know if that's actually set all the time on decompose. I guess I can see where it's called. We need to make sure that it's always set correctly. So is it set in this case? Is function offset set correctly? I don't think it is, right? In fact, I don't even think it has a bitstream because it's just a function call. Well, we're not even, okay, in that context, we're not setting look ahead. Let's find this, okay, here's a context where it might be set. Does part have offset set? Yes, it does. But we could just, you know, just to be safe, I guess we can just call this ourselves. This is exactly what I want to do, right? I want to do this, but I want to save it like in a local variable. So like, just define it like const auto initial offset, right? And then it's just component arrow bitstream arrow get read offset, right? And then we want to put in a function object into the cleanup functions that rewinds things. So that's just we just need this, and we need component. We don't need path. Actually, I don't even think we need this. We need initial offset. Right, so then it's just, yeah, isn't it just component bitstream set read offset to initial offset? I think that's all I need to do, right? We're done. Let's see if it works. Oop, terminal, go to the end, run it again. Did it work? Oh, I think it worked. I think it worked. Look at this. So the next is 57, and then we parse it as 57. Right. And then it hasn't, the outer doesn't have a value. Okay, because this is just a dummy thing. Okay, it's working. Great. So then if we filled in actual syntax for data, this would actually work, right? The other thing is I'd like this next not to be put into GIF at all. Because right now, if I do a report at the end, we end up with a bunch of nexts, right? We have all these datas, and then we have all this, but at the end we should have a bunch of nexts, which is not what I want. These reports are pretty big. I know, holy late stream, Nightshade dude. I'm updating the grammar of my language and it's working. Okay, so my objective now, okay, actually there's two problems. This should not be scrambled, and we need to get rid of this. So I want that not to be saved because it's useless. But this is more depressing because I thought I fixed that. Did I not save it? Did I not save it? That should be fixed. Let me go to the other window and make sure that when I build parse format and I run it, yeah, that's correct, right? Oh, no, it's not. It's broken again. I think I know what happened. I was showing Togglebit what I was doing, and I undid it by mistake, and no one caught me. Yeah, that's in the grammar file, right, where we specify order of operations. I think I must have undid it. Yeah. Order of operations, it's from least to greatest. We need left and right shift to be greater than. Okay, so that's fine. Let's verify I fixed it. See, the problem is just never show Togglebit stuff, right? Where is that? Yeah, now it's correct, right? So it's an order of operations thing. I had a bug in here under LEUI, right? So little endian unsigned integer is parsed to least significant byte first, then the most significant byte, and then left shift the MSB 8 and then add the LSB, right? And it didn't use parentheses because I was counting on the order of operations to be correct, and I had a bug, and now I fixed the bug. We ready for Nightshade dude? We talked about this, right? We could do that, but then it would be hard for everybody but you and me to read. Hey, let's do it anyway. Here would be the reverse Polish notation way of doing that. It would be thus. It would be MSB 8 left shift LSB plus return. Perfectly readable, don't you agree? Nightshade dude, both of us can read that. No one else can. Although it would take me a moment because I would see these and I'd be, what? Shouldn't there be something in between those two things? And that'd be, oh yeah, reverse Polish notation. Push, push, Pop2, do the operation. Push, pop2, do the operation. Pop, do operation. I know it's great, but you have to have a stack. You don't have a stack? Gotta have that. Syndev, I love pie. Yeah, if you have a stack, sure. But then that's not how we were taught in school to do math, right? Well, at least some of us. Okay, anyway, I fixed that bug again. Let me build decompose and run it. And I should have the correct values now for, yeah, here we go. The logical screen. Actually, it's at the very end. Okay. Yeah, we need to get rid of next. Yeah, but see here, now it's correct, right? So it's 300 by 300. That's what I wanted to see. That's where you disagree, and you shouldn't see all the stupid posts on social media of what's the correct answer. Reverse polish makes sense. I didn't say it makes more sense. True. True. Okay, I think the way to get rid of this next table, which we don't need, is to not give it a name at all, or to use a local. I think that's what I had before, right? That's the reason why I had this thing called local. So yeah, I define a local next. And then I think the way to do this is, I don't do that, right? I have to cheat and look outside the stream for a second, because I had this in another window. It's just inconvenient to pull it into the stream. Yeah, okay. That's how I did it. Oh, it's backwards. Oh, no, I don't need to give it a name, right? Yeah, so it would just be arrow next. It looks funky, but it's basically saying parse a unsigned integer looking ahead. Now that's the new syntax, and then write it to the local variable called next, constrained to 8 bits. If we gave it a name next, then we would also have a next table in the output, but we don't want the table. We just want the arrow there. I think that's how we do it. Yeah, that worked, right? Yeah. Actually, no, it didn't, because now we have UI. Why is it actually saving it? It shouldn't save it. It shouldn't have filled this in. Oh, it thought that was the name? Oh, bummer. Do I have to give it a name? Hold on. I'm looking off to the side again. What was it? It looks like I always gave it a name, but then we just abandoned the name. Okay, let's try that. So, let's give it a name and just not use it and see what I get. Yeah, see, it still puts it in the table. I don't want it to show up in the table. Like, that should just have like a no name. So if I don't do that, I get a syntax error, right? Oh, no, it actually works. It actually worked, but then what's the name of this thing? It's just called UI still. Oh, but then there's a next. Right, that's the local that gets removed. Okay, so that, if it's local, it gets removed from the report. All right, so next doesn't appear here anymore, but this does, which is weird because it's there, but it has no name. Okay, the whole point of that was for it to be temporary only, so I guess just I should see how this works when there is no name. So how does the grammar look? The grammar is up here for part, where, here we go, part. So it's this optional ID, right? I don't have it in the comments here. A comment talks about subformat, part, args. Oh, part. Optional reference to where to put the part in the composition. So yeah, if it's optional, that implies that if we don't give one, it shouldn't be part of the composition. But right now it is somehow. So that's where I need to figure out what's going on. Actually, you know what? I wonder. I think I might know what it is. I think it's because it's within a loop. Because we're in a loop. I think if I did it out here, like if I oh wait, this isn't given a name either, and yet it's still stored, right? Right. So it's always going to be in the report. It's just not going to have a name. Is that's okay, right? Oh no, it has a name. It has a name, but it's the default name is the same name as the syntax. Is that right? Okay, I need to look at the code. The grammar made it seem like it was okay. It's put in the composition, but where is it put if we don't give the reference? Yeah, this L value syntax, that's what I'm doing with the arrow. And the reason I'm doing that is to take it out of the loop. So the idea is take it out of the loop so that we don't actually store it in as an array. But it's still doing that, and I don't want that. And I think the problem is that it's saying assign a copy. So that means the part always exists, which is what I don't want. So I need there to be a way to not store it at all. See, the thing is I can't have it both ways, right? This doesn't specify a name either. If I did, it would be this, which is valid because now it's going to be called header, right? But this implies I don't want it to give it a name, but yet it still gets a default name. I'm undecided what I want to do here. Maybe I should sleep on it. Okay, but at least I got the look ahead stuff working. It's just that I haven't just decided how to hide things that we parse that we don't care about. So I shouldn't care about this. I want it not to be stored. That's actually a to-do we need to add here. So new to-do, figure out how to specify a part we don't want to actually include. Actually, then the better way to say this is figure out how to specify a part to be excluded from a composite. That's exactly what I want. The composite is GIF. I don't want to include this next byte because we're only using it to look ahead, right? So I need a way to specify how to exclude it. We did the look ahead. What was that? I forget what the key is. To do toggle done, Alt D. Done, yay. Okay, so then yeah, haven't done that. That's a low priority. That's also low priority, I think. This I should have because right now I'm hijacking another type, which is gross. And led to a bug that I had to fix. So I'll probably do this tomorrow morning. And before I forget, I need to send this out of the virtual machine. I need to do that from one directory up, 2 directories up. I don't want to lose my work, right? So I want to send that out of the virtual machine. And then let me make sure that I actually received it outside. You won't be able to see me type this, but I'm outside the VM, I'm typing poll, and then it should show up as differences in Git. And it does? Yeah, okay, so then I decided for this project for DataDisintegrator, I'm not gonna do the Git junk on stream. I'm gonna do it off stream, and that way, like, because it really doesn't make sense because it's not in GitHub, it's a private repo anyway. So why distract you guys by doing Git stuff? I just need to send it. I just need to remember to send it out of the VMs to check it into Git later. So yeah, we have the specification of the outermost stuff done. We just need to clean up this syntax or figure out a new syntax to say basically ignore that. Actually, if we had the ignore, then I wouldn't need the. Actually, no, I do need the local, right? Actually, maybe the way we specify it is we could mark it. We could just say that it's next, like that, and then we mark it somehow to basically like drop it and not store it. So like basically remove it when we're done, right? So maybe the way actually let me think about how I would do that. Would that be another change to the syntax here? How about if we do like exclamation point, or maybe exclamation point outside here, some extra character that says if we see that, then so no, it has to be something that like kind of I can figure out by looking at it. The plus meant to me like ahead, look ahead. But what character or way to mark this up? I know. Just like Rust, I'll use underscore. And then by convention, we'll drop anything that has an underscore. That's what we'll do. So we'll just basically, when we're done with the whole composition, we'll go back and delete all the underscored parts. And so they're only used during parsing and then they're stripped. So basically I want to see header, I want to see logical screen, I want to see data and trailer, but I don't want to see next. Yet I do want to define next with the look ahead syntax and be able to use it to break out of my loop. So it's not truly infinite. Yeah, I like that. Okay. So specifications done there out on the outer side. I need to complete the data. Right now it's just dummy and I didn't finish that. And I need to actually implement the stripping of the next, which is in this to do. Actually, let me make another to do so I don't forget to finish the full git, not git, GIF specification. Right? Because why not? That'd be a really good test. If I can parse every single bit of a GIF or a GIF, however you want to say it, then that'd be a good test. So what screen do I leave you guys with while I'm trying to make a raid here? I guess what I'll do is I'll show how this gets parsed. Where directory were we in? Was it stage? No, it was build. And decompose, right? Yep. Cool. And let's less that and then kind of look at this. Is it because we have this other window? No, that's Oh, there, that's what it was. Because when we have two shells, it does a wraparound on this. That's what it is. We only have one shell, it doesn't show that panel on this. Nice. So yeah, so this is sort of a summary of what we did today. We got specified GIF, and the tool can actually parse the real GIF. Yep, I'm going to late Nightshade dude. See you later. Let's find some other raidable stream. How about we raid Adam C. Eunice? He's doing something completely different, a completely different language. I hope you will enjoy his stream. I'll see you guys tomorrow, okay? And hello, other Adam. Adam, I'm going to introduce you to the other Adam that I know. Yeah. Hello and goodbye. See you, Nate. Bye.